Hello everybody, welcome to your next GeoBoost video. Now the second part of the ground source heat pump systems in the Submodule 1.4. I want to tell you now a little bit about groundwater heat pumps and open loop systems. Open loop systems are normally based on two wells. So we have one well's abstraction well and one injection well. So we abstract water here, lead it to the heat pump, and then inject it back. Why we are injecting it back? Because we just want to use the heat and not want to change the volume of the groundwater. So we have to see that we have enough groundwater here, and then we have to design it in a specific way. So also the distance between the wells here plays a role, that we are not actually pumping out the water here what we injected back. So this is a cold water. We do not want to pump it back. So there must be a specific distance that we do not have a so-called thermal recycling. So we have specific parameters and a specific situation how to set up such a groundwater heat pump. So here you see the design of a pumping well, injection well for the design. This is normal also like a drinking water well. So we have to design it in consideration with the underground parameters like the hydraulic conductivity. Has it a high hydraulic conductivity, then it is actually we can pump out a lot more water. If we have a high groundwater thickness, we can also pump out a lot more water. So we have to design our pumping well with consideration of the underground parameters and also the injection well. It is necessary that we inject back all water what we pumped out, of course. So there are some constraints what we have to consider, as I said before. So what are the main factors? The main factors is how productive is our aquifer. So what is the hydraulic conductivity and the aquifer thickness, as I said before. Also, what is very important is what is the depth to the water table. So we have to know how deep we have to drill, and also what is the saturated thickness. So how much groundwater do we have? Normally, it is recommended that we fully penetrating the wells, so we actually use the whole of the saturated thickness of the aquifer. But in practice, you see also that it is not fully penetrated, that it is actually drilled just a few meters in the aquifer. Sometimes this works as well, but recommended is a fully penetrating. Then, of course, also the abstraction well, you should not use all the water what you have here, so not pump actually the aquifer dry. So normally it is recommended that you have a maximum drawdown of 1/3 of the saturated thickness. So these actually guarantee also that you have enough water for the groundwater heat pump if we have a dry season or something like that. And then, of course, you should also consider the injection well that is not causing flooding. So you need, if you inject the water back, you need a distance to the surface. One threshold, which we know is 0.5 meter, should be the distance to the ground surface, or underground structures which should not be affected by groundwater flooding. So, and as I said before, the wells should be spaced as far as possible in order to avoid thermal interactions. So a thermal recycling. And normally, if you have a high distance between production and injection, you can use the whole productivity of the aquifer. Of course, you can use groundwater also for cooling, which you see here. This is actually a district cooling network, and it is used here a lot of wells, which you see here, and to cool down a lot of buildings, data centers, and so on. This is very efficient. The groundwater is used directly, so without a heat pump, which has a very high efficiency. But you can use also groundwater for a standing column well. So this is just a one well system, not a system with with a production and injection well. You produce out of this well and inject in the same well. This actually limits the effort to drill two wells, of course. But on the other side, you have specific conditions that this works well because, of course, the thermal interference, there's a little bit of risk that the efficiency goes down if you pump too much and if the conditions are not really linked to such a standing column well. So this is good. You save also space for installation, but you have to see that the efficiency of these standing column wells fits to the thermal demand what you have. And at the end, you can use also a so-called ATIS system, so the groundwater body or the aquifer for storage. So you can actually also some waste energy or what you have left, you can actually store in the underground, for example, in summertime, and then actually get it back in wintertime so that you can use the IT system as a storage. And here you see such a load curve. So it is needed for the storage. So you have normally in summertime a heating mode, and in wintertime a heating mode, and in summertime a cooling mode. So you can use the IT system for cooling and heating, which is quite very favorable and increase the efficiency.